Hello everyone. From this video onwards, we are going to have a look at a few coding exercises. So what I will do is that in each video, I'll provide a few questions, which will be a practice question for you in terms of JavaScript. And what you have to do is that you have to implement the solution after I describe the problem. So after I describe the problem, I will also describe the solution, but you can pause the video and then you can firstly implement it yourself and then you can watch the solution. Okay, so for example, the first problem is you have to find the smallest prime number which is greater than n, which means that some number n is given. Okay, and we have to find the smallest prime number which is greater than n. So if n itself is prime, that also does not matter. I have to just get a number greater than n and that should be prime. Okay, so I know that 5 is a prime number, right? But still, if I try to find a prime number greater than 5, then that will be 7, right? And if I have, let's say, 3, right, then the prime number which is greater than 3 is 5, that is fine. And if I want to get a prime number which is greater than 13, then that will be 17. And this should work for any number. So for example, I have to get a prime number which is the next prime number of any prime number which is just after 90. Okay, so that will be 97. So in that fashion, you have to implement this solution. Now, as you can understand that now, if you have gone through the video of JavaScript modules, then you know that I can implement a solution in in a different file. So for example, in solution.js, let's say I implement the solution, then I can import that solution, and then if the default export is a function, then I can call that function here. So you can clearly see that this implementation correctly works for our use case where we have to find the smallest prime number greater than a given number. Okay, so now you can pause this video and then you can implement it yourself and then we can discuss the solution. Okay, so now let's start the implementation of this problem. So let's start with a small number. So let's say 5, and I want to get a prime number, smallest prime number, which is just greater than 5. Okay, so in this solution.js file, I have just a bare bones structure. I'm not doing anything. So for example, you can just see that I'm just printing n, which means that n is passed from here, and nothing is written, which means undefined will be written. So if I run this code right now, then I will see that yeah, that 5 is printed, but nothing is written. That's why console log is doing undefined. But that is not what we want. We want to find a prime number which is greater than n. Okay, so let's start. The first thing we have to do is that from n, so like n plus 1, n plus 2, these things I have to check that whether that thing is prime or not. So firstly, let's implement a small method to check that something is prime or not. So right now, let's implement a method, something like is prime, and in that pass some number n, and I'm trying to check that whether this number n which I'm passing is prime or not. Okay, which means that if it is prime, then I'm going to return true. If it is not prime, then I'm going to return false. So that is the scenario. Okay, and we can then use let's say right now 5 is called, right? So let's simply print that is 5 a prime number or not. So right now I'm not seeing the next number or something. I'm just right now just trying to check that whether my prime number prime function is working or not. So let's firstly implement and then we'll check. So rather than 5, just n, whatever n we pass, that should be checked. Okay, let's see. So what we can do is that the first thing we can do is that we know that prime numbers will be prime numbers are those numbers which are not divisible by any other number other than 1, which divides everything, and the number itself, which will obviously divide itself. Okay, so apart from 1 and n, that number itself, nothing else should divide, which means that let's say the number is let's say n only, then I will not check for 1, I will start from 2, and then I will check for 3, I will check for 4, till I will check till n minus 1, right? So let's say n is 90, n is 90, I have to check that whether 90 is a prime number or not, right? Then from 2 till 89 I have to check that whether anything divides it or not. Obviously 90 will divide, obviously 1 will divide, so there is no point in checking those, because that is not as per the definition of the prime. From 2 to 89 we have to check. So in a similar manner we can write a for loop. So let's say for if we start from 2 and we go all the way till n minus 1, so let's say I less than n. So sorry, starting with 2 and till n minus 1. Okay, if we are getting anything, if this is not needed, if my n is divisible by I, so I is 2, 3, 4 like that, right? If my n is divisible by I, which means that remainder is 0, then I know that this cannot be a prime, because I have found a divisor which divides n, right? And that's why in that case I will return false. It cannot be a prime. And if it runs with or with all the values and still it does not find, it comes out of the loop, and which means that from 2 till n minus 1 it has not found any divisor, which means that it is a prime, and that's why eventually we will return true, which means that it is a prime number. Okay, that should be fine. So let's run this, and we are seeing that yeah, it is giving us true, that is fine. And if we are checking, let's say for something non-prime, let's say 6, then it is giving us false, so that is fine, so it is working fine. It is working fine. Now what we have to do is that we have to find a let's say whatever n is provided. So I don't have to check for n. From n plus 1, n plus 2, n plus 3, the smallest one, which is a prime, that I have to return, that number I have to return, right? Now for that what we can do is that we can, let's say, take a variable t which starts with n, that is fine. But I have to start checking from n plus 1. So what I can do is that I can run a while loop, and this loop will run till I get so if definitely after every number there must be some other prime number, right? So there is no condition here. Directly inside the while loop, as soon as we get the next prime number, then we will break. Okay, so it will not run into infinite loop, so no need to worry. So while true, and now let's say I'm checking let's say I'm starting with t plus plus, which means that I have incremented t, which means that first time t is now n plus 1. And now I'm checking that if my current t, like right now first time it is n plus 1, if n plus 1 is prime, then what we is prime, then we have found our prime number, right? And then that's why return t. What happens if I have not got it? Then this thing will not run, then this loop will again keep on running. So next time it will be again t plus plus, which means that now it will be n plus 2, and again n plus 2 will be checked. Is n plus 2 prime? If yes, then that n plus 2 will be returned, otherwise n plus 3. That will keep on this will keep on doing, and we don't need to break anything, because whenever the next prime number is found, then from the while loop, if you return then automatically this while loop will be closed, because this while loop is inside a function, and as soon as we execute return, then this solution function will be terminated with this return value, and this while loop will be automatically executed, so we don't need to break it or something. Okay, so that is fine. So let's delete this, and yeah, that should be fine. So let's test it for 6. So you can see that it is returning 7, which means that uh, which means that if this thing is 6, which means that I have checked for 7 and I have got that it is prime. So which means that if I pass 5, then also it is giving me 7. So if 5, then it checked for 6 and it saw that it is not prime, then it checked for 7, then it saw that it's prime and then returned 7. So that is how it is working. Okay, so this solution is working fine. Now what we have to do is that we have to optimize this code. Actually, right now what we are doing is that we are while we are checking this code, while we are trying to check that whether a number is prime or not. In that case, we are going from 2 till all the way till n minus 1. Turns out that you don't need to go till n minus 1. Even if you go till root n, then also it will work fine. Let's try to understand why that is the case. So let's take an example. So let's say 8, for example. What are the factors of 8? So the factors of 8 is 1, 2, 4, 8. Okay. For that matter, let's consider 16. Right. What are the factors of 16? 1, 2, 4, 8, 16. Okay. So you see a pattern. What is happening is that if one so obviously 1 will divide and then the 1 into 8 will be 8, and similarly 1 into 16 is 16, but that is the trivial case. Let's start from 2 here, and here also let's start from 2. So what happens that 2 into 4 is 8, which means that if I have checked that 2 is dividing 8, then I don't need to again check for 4 from that side, right? So somehow can we come till middle, and if we check the half of them, then that is enough rather than going to the next step. And what is the middle one? Middle one is actually the square root of that number. You can see that in this case 1 into 16 is 16, that is fine. 2 into 8 is 16, and then 4 square is 16, which means that if there would have been any factor of 16, then definitely that would have come I before root n. So in this case, root n is like root 8 is like between 2 and 4. So obviously it will go till maximum 2. In this case, it will go maximum till 4, which means that I just have to check from 2 till 4. So for 2, 3 and 4, I will check for only these 3. And if because if 2, 3, 4 did not give me any factor, then there will be not any other part of the factor which will multiply it to give us that number. And that's why it is enough to check till the root, because we can clearly see that all the factors come in pairs. All the factors come in pairs, which means that x into y. So some x is before root n, and some y is after root n, and that x into y is giving us that number, right? And in the most edge case, that x and y, if they are both equal, then x into y is basically x into x, which is x square, and that is that number. And that's why that middle number will be root n in the corner case. Otherwise one factor will be before root n, second factor will be after root n, and that's why we don't need to go till n minus 1. We just need to go till less than or equal to square root of n. Okay, so yeah, you can do something like this also, that math dot sqrt n, but you don't need to do this. Why? Because a simpler way is simply doing I into I is less than equal to n. Same thing, right? I square is less than or equal to n, which essentially means that I is less than or equal to root n. In this, you are not using some special function, so that will be fine. And you can still see that I have just changed n like n minus 1 to square root of n sort of thing, but still I don't need to change anything here. This thing works perfectly as earlier. So you can see that if I give let's say some value like 13, right, then the next prime is 17, 90, and the next prime is 97. So you can see that it is working still perfectly. Now once you have implemented this solution, right, then actually I have written a test case where, like, a couple of tests, 2, 3, 4 tests I have written, and that you can test, you can use that thing to check that whether your solution is correct or not. Okay, that that test thing is written in a file, in JavaScript file, and that is hosted at a public URL which can be easily accessed by you. I will share this link in the description of this video on the YouTube. So right now, let's take this thing and copy paste this whole thing and see what is there. So it is actually, what it is doing is that we are using a new function called console.assert. What console.assert does is that whatever the first argument if you are passing, if that thing is true, so let's check for the just the first one. Okay, instead of 7, let's say 8, right? Then what it does is that it checks that whether this thing is true. This solution 5 will return 7. 7 is equal to 8. This is false, right? If this thing is false, if the first argument is false, then your assert fails and it will write some warning on the screen. So you can see that assertion failed, and then you can write some any custom text here, and that will come here. Okay, so just to check that which test failed. You can clearly see that this thing happen, and if it is 7, then you can see that nothing will happen, only done is printed at the end, and this thing is silent. So console.assert is silent when the first argument is true. Console.assert prints a warning on the console regarding assertion failing if the first argument is false. So if we are writing something like this, which means that if our function returns all these values correctly, then everything should be silent, and that's why you can see that done, which means that nothing is printed, which means that all these are passing correctly. So your solution, if your solution, implemented solution, is also passing all these tests correctly, which means that most definitely you must have written your solution correctly. Okay, so yeah, you can use this file whose link I will put in the description to test your function. So that will be all for this one, finding the smallest prime number greater than n. In the next video, we are going to have a different problem related to JavaScript implementation.